Lesson 10.3, Task 5. Real-world problems modeled by logarithmic equations. When solving a real-world problem algebraically, always check that your solution makes sense in the context of the situation. For example, distance in the real world is non-negative. However, sometimes a negative value for a distance does make sense in the context of the situation because it means below, to the left, or behind the starting point. An example, in some contexts, a negative value for altitude can mean below sea level. Often the real world restricts values to positive numbers. For example, if a box can be modeled with dimensions x, 10 minus 2x, and 15 minus 2x, the volume is modeled by the function v equals x times 10x minus 2x times 15 minus 2x. Remember, volume is length times width times height, with the domain being restricted to x between 0 and 5. For any other value of x, at least one of the dimensions of the box is negative, which does not make sense. All right, so volume, again, length times width times height. Those dimensions could not be negative because that would not make sense. All right. Pollux has an apparent magnitude of 1.16 and an absolute magnitude of 1.09. The brightness of a star is measured from Earth is the apparent magnitude m. The absolute magnitude, capital M, is the brightness of the star from a standard distance of 10 parsecs. These measures are related by the formula. M minus M equals 5 log of d over 10, where d is the distance of the star from Earth measured in parsecs. How far is the star Pollux from Earth? All right, so we have lowercase m minus capital M. So it says apparent magnitude is the lowercase m, so that's 1.16, and your absolute magnitude is the capital M, 1.09. So we can take the formula and we can substitute what's given from the picture to solve. So 1.16 minus 1.09, if you subtract those, you're going to get 0.07 equals 5 log of d divided by 10. Then you're going to divide both sides by 5 to isolate the logarithm, and you're going to get 0.014 equals log of d over 10. Now that we have this in logarithmic form, you can rewrite it again using the definition of log. I'm going to write this out one more time. So you got log base x equals y. That means this goes to this and this. So here's going to be base to the y power equals x. All right, so that's an if and only if statement. So when we get to this line right here, since this does not have a base, it's assumed to be base 10. So they're going to rewrite this as base 10 to this power right here equals d over 10. And that comes from just this definition of logarithm here. All right, and then we can solve for d. Okay, so to get d by itself, you're going to multiply both sides by 10. So 10 times 10 to this power is going to be approximately 10.3. All right, remember your distance is measured in parsecs. Not familiar with that, but maybe it's something to look up. All right, the star Pollux is about 10.3 parsecs from Earth. How does the third step follow from the line above? All right, so the third step is right here. So the line above it, we divided by 5. So that's the division property of equality. And then it says, what is the justification for the fourth step? So when we went from here to here, so that's the definition of logarithm again. And how can you use a graphing calculator to verify the answer? All right, so you could graph it. And this, you'd have to set this side equal to the other side. So right here we've got 5 log of d over 10 equals 0.07. And the solution should match the x value of the intersection. Remember, the x value is the solution. All right, if 10 parsecs are equivalent to approximately 32.6 light years, how would you calculate the distance between Pollux and Earth in light years? All right, so you would just have to multiply by this divided by 10. So if you divide this by 10, you'd just be multiplying by 3.26 light years away. All right, is it reasonable to say that Pollux is about 30 light years away from Earth? Well, let's see. All right, so if we've got the 10.3 is the distance. So let's take the distance and multiply it by the light years. So we're going to have 10.3 times, and then 32.6 divided by the 10 parsecs, again, that's just 3.26. So I'm going to multiply that by 3.26. That just eliminates one step here. So the 3.26 is this already divided by 10. It just moves it over one decimal place. And we're going to hit enter. And it says, is it reasonable to say it's about 30 light years away? And that would be yes. Rounding to the nearest tenth, the distance would be 33.6 light years away. All right, F says review the steps used in the solution above using the given formula. What is the general equation for D? All right, so all they're asking you to do there is solve for D. We've done that back in Algebra 1 and, Math 1 and Math 2. So just take your original equation and solve that for D. You would have to divide by 5, then rewrite that, and then multiply by 10 at the end. So basically doing this process except without filling in the numbers. All right, that is, I think, all for task 5. If you have any questions,